In this video, we're going to discuss how to deal with a situation in which you have more than a 2x2 table. Let's take, for example, the crosstab with ethnicity versus myopia. Now, you see there's a few blanks, so I have pre-selected out cases that have blanks. So I said if ethnic is not equal to, and then those are just quotation marks. Two quotation marks with nothing in between. That's equivalent to a blank. These data are not missing in Excel because it's a string variable and it sees it as it just doesn't read it as missing. So you have to do it as blanks. If this had been a numeric variable and we had coded this, we could then say missing cismis, not equal to cismis ethnicity. Anyhow, so descriptive crosstabs. Let's look at ethnic in the rows, myopic in the columns. Our cells, we want to have expected values. We want to look at row percent. And we want our statistics to be chi-squared. Continue. Okay. So what do we get? We get a very significant chi-square. Now, the problem is you can look at each of these cases. For example, the expected count of not being myopic for Asians was 458, and the actual observed was less than that. The expected was 88. Of those that had myopia, that was higher. Asians get myopia at a higher rate. Now, the question you might ask yourself is, of all of these, is that what makes up this significance? Is that what makes it a significant difference? So there is a handy little way of determining which groups are different, because all we know from here is that this chi-square says it's rejected the null hypothesis of no relationship. So we conclude that there is a relationship between myopia and ethnicity. But where is it? Where is this relationship? Where does it manifest itself the most? So let's go into our little table again, and let's go over to cells. And we have over here residuals. We have unstandardized residuals, which would just subtract the two numbers. Standardized, which is an okay option, and it's easy to kind of understand what standardized residuals are. Standard residuals are basically if we just take the square root of observed minus expected. This is the chi-square formula. We have observed minus expected over the square root of expected. So we take the square root of this internal, and that's for a particular cell. That's the adjusted residual. Wow. For a particular cell. Okay, enough of my artwork. So that is standardized, and then adjusted standardized is handy when you have cells that vary in size. Like this is 1200 and that's 547. It kind of adjusts for unequal sample sizes across the marginal totals. So let's pick that one. What do we get? Well, we get this adjusted residual minus 6.3. Now remember how we were talking about the this being equivalent to variance, this is like a standard deviation or a t-test. It's actually like a t-test. And so as it is like a t-test or a z-test, to the extent that that is true, which it is true, then this is a z-score. And if you're outside 2 z-scores from the 0, then you can say it's significantly different. So even though that's a -6, its absolute value of 2, it's a number that's greater, the absolute value is greater than 2. The absolute value is greater than 2. So absolute is greater than 2. Absolute is less than 2. Whoops. So Asians with this 6.3, for those who develop myopia, they're 6 standard deviations out, or 6 z-score units out, and would be considered very significant, or would be considered significant. And then the -1.9, so African Americans don't really differ from chance. Hispanics are a little over, and Caucasians are way under, so their 197 expected value is much bigger than the actual 118. So a standardized residual is a very, very handy way of determining if you have significance in any particular cell.